While we are highly trained professionals dealing in complex mathematical procedure, we do encourage you to try this at home as it will hopefully enhance your mathematical understanding. So welcome back to One Lesson 3 Math. We have a 10 minutes, 10 marks video here where you can attempt the questions and then check your solutions as I give the explanations. So if you'd like to have a go at the questions, please pause the video now and then I'll proceed with the solutions. So question 1 is to expand and simplify. First of all, part A, everyone likes a good part A. We've got a double bracket and the brackets are touching each other. And when the brackets are set up like this, it means it's the first bracket multiplied by the second bracket. So here we're going to use FOIL, first, outer, inner, last, and this is to be used when the brackets are touching each other. They're next to each other. Okay, so we're going to multiply the first bracket by the second bracket, and we're going to start off by doing x multiplied by x, then x multiplied by minus 3, then 9 multiplied by x, then positive 9 multiplied by minus 3. So x multiplied by x gives us x squared. X multiplied by minus 3 gives us minus 3x. Then we've got positive 9 times by x, so that's plus 9x. And then finally we've got plus 9 multiplied by minus 3. A positive times a negative is a negative, so that's minus 27. Then we look to simplify. We can't simplify the x squared because there's no other like terms. We can't simplify the minus 27 because there's no other like terms. However, we can simplify the minus 3x plus 9x. Minus 3 plus 9 is positive 6. So our solution here is going to be x squared plus 6x minus 27. So that's a nice example of FOIL where the brackets are touching each other. Part B, however, we have the first bracket and then we're going to subtract the second bracket from it. So here what we're going to do is we're going to expand the brackets independently. It's not FOIL, so I'm going to multiply out the first bracket. 3 times 4a and 3 times 3b. That gives me 3 times 4a is 12a and 3 times 3b is positive, so it's plus 9b. So that's the first bracket dealt with. Now the second bracket we need to be careful with because it's minus 2 times by the terms in the bracket. So minus 2 times 3b and minus 2 times by minus 7a. Now that gives us minus 6b plus 14a because minus 2 times 3b gives minus 6b, but minus 2 multiplied by minus 7a, minus times a minus is a plus, so that's plus 14a. Then we need to simplify, so we collect the like terms. 12a plus 14a gives us 26a. Positive 9b take away 6b. We're going to have plus 3b. And that's our solution. We can't simplify that any further, so they would be the marks for questions A and B from part 1. Question 2 says, Chris Mastery has a big bag of sweets. The numbers of different sweets are shown in the table. So we've got 3 types of sweets. We've got toffee, we've got mint, we've got Haribo, and we've got the number of sweets, 5, 8, and 7, respectively. So part A, everyone likes a good part A. Write down the probability that he randomly picks out a mint. So first of all, how many mints are there? There's 8. So there's 8 possibilities that he picks out a mint. The total number of sweets is 5 plus 8 plus 7, which is 20. So it's going to be 8 out of 20. 8 is our numerator. I'm going to write P for probability, mint in the brackets. That's how we write down a probability. And it's going to be 8 over 20. That simplifies. We could divide by 2 and get 4 over 10, but we could actually divide by 4 and we will have a simplified fraction of 2 fifths. Now you could also write your probability as a decimal or as a percentage, but fractions are completely fine. But if you had written it as a fraction or a percentage, then what you would have is 0.4 or 40%. So, part B. Write down the probability that he randomly picks out a mint or a toffee. So here we've got to add up mints and toffees. Mints and toffees add up to 13. So our probability is going to be 13 out of 20. That doesn't simplify. Remember, 13 is a prime number that only divides by itself and 1. But as a decimal or as a percentage, we could write 13 out of 20 as a 0.65 decimal or 65%. It's probably best in these situations to stick to the fractions because it's easy to find your denominator by adding the total together and taking the numerator as the possibilities, the events that you are being asked to identify. In this case, a mint or a toffee, and in part A, the probability of a mint. Question 3 says write down the following in standard form. So we've got to put our decimal point after our first significant figure. So the first one is going to be 4.59, always multiplied by 10, and we need to see how many places the decimal point has effectively moved. The number we have is 4,590,000, and we should know by now that millions are 10 to the power of 6. So our solution for the first question is 4.59 times 10 to the 6. For part B, we have a decimal of 0.0087. The decimal point has to go after the first significant figure. So we're going to put our decimal point after the 8, 8.7 times 10. Now we've got 3 zeros, we can zero count for decimals, 3 zeros, so it's going to be times 10 to the minus 3. Part C, the way to do this is to multiply the integers, the numbers, first of all. So I'm going to start off by doing 3 times 4 and 10 to the 4 times 10 to the 7, using my knowledge of multiplying indices together. So 3 times 4 is 12, 10 to the 4 times 10 to the 7, we add the powers together, so that's going to be 10 to the 11. Now 12 is not in standard form, so I need to convert 12 to standard form so that my decimal point is after my first significant figure. So 12 in standard form is going to be, let's just get it onto the screen. 12 in standard form is, I'm just going to jump back there, is 1.2 times 10 to the 1. 1.2 times 10 basically. But to help us answer this question, we can now write 12 as 1.2 times 10 to the 1 multiplied by 10 to the 11. So then again, using my laws of indices, I'm just going to move that up a little bit. Using my laws of indices, that's going to be 1.2 times 10 to the 12. And that's my final answer. That's my answer in standard form. Now, question 4, Pterodactyl watches various DVDs. The relative frequency, that's the probability, is shown in the table below. So we've got 4 DVDs. We've got Combat Unicorns, Frogs on the Run, Hamsters for Wheel, and Big Bad Koala. Now, the relative frequencies are as follows. Of Combat Unicorns, it's 0.4, Frogs on the Run is 0.03, Hamsters for Wheel is 0.29, and we don't have the relative frequency of Big Bad Koala. So find the relative frequency Pterodactyl watches Big Bad Koala. Well, what we can do, and I always find it easier to change these relative frequencies to percentages. 0.4 is 40%, 0.03 is 3%, and Hamsters for Wheel is 29%. So what I can do is I can add these together. Remember that one of the 4 events has to happen The 4 events probabilities added together is going to add up to 100%, or 1 if we were adding the decimals. But using 100%, we can add those percents together and we get 72%. We can take that away from 100% and we get 28%. That converts nice and easily to a decimal. So our solution for part A, everyone likes a good part A, is 0.28. So that's the probability that pterodactyl watches Big Bad Koala. Part B says if pterodactyl watches 300 DVDs, estimate the number of times he watches Combat Unicorns. So there's a number of ways of doing this. We can start off by saying, well, we can do 0.4, that's the probability that he watches Combat Unicorns, multiplied by 300. Now, a nice way of doing that, as you can see, is saying, well, 300 is 10 times 30, 0.4 times 10 is 4. So we can then do 4 times 30 and it's 120. But if you wanted to use the percentages, you could say, well, 10% is going to be 30, 10% multiplied by 4 is 30 times 4, and that would also give us 120 as our answer. So, I hope that's been a useful video. I'll be back with more videos later on. Hasta la pizza, arrivederci, so long, goodbye, au revoir, ciao for now, we will see you next time.